I'm Jerry Docherty and I'm the chair of the judging panel for this year's Young Software Engineer. The awards are now more than 30 years old. In the early 1990s, when these awards began, only a limited number of universities were teaching computing sciences. And part of the reason for us creating the awards was to encourage more students to study computing science at universities. Of course, since then the sector has seen great change. We've seen the introduction of the internet, new social media applications, the development of data sciences as a major topic, and now the introduction of artificial intelligence. This means that the number of topics which the judging panel look at are becoming more varied and more complex and frankly more interesting and exciting. Let me now introduce the class of 2023.
I'm Michael Sutty. I studied software engineering at Edinburgh Napier University, and my project was the role of Formula One based telemetry and its impact on improving lap times for amateur sim racers. During COVID, a lot of live sports got cancelled and a lot of people moved on to virtual sports or esports. And Formula One was the same. They did that and it was arguably the most successful of the lot of the sports that did it. All of the drivers in real life use a system called telemetry, and that transmits all the data back to the factory or the garage, and they use a software or applications to analyse that data. There's never been a sort of market for an amateur looking to get into this, so I developed an app that would fix that with the Formula One games. It's all about the fine margins in Formula One, and again it translates to online. So the more you know about how you're performing and why you're doing it well or wrong, the quicker you can go on track. The biggest challenge was actually getting the data from the game to the application. So I eventually managed to find someone that done that open source, and that was kind of the start of me actually getting the ball rolling, because that was the big problem to begin with, was figuring out how do I get this unordered data into a format that I can use within the time frame of an honours project. I kind of plan to add more functionality to it in comparison to what it has now. I'd ideally like it so that the track is dynamic, so you can use a slider that'll move a little dot to represent the car on the track, and also move the data on the graphs. That way it's all there, it's all one. But it would also be quite interesting to do everything from the ground up with what I know now, with all the time that I've got, instead of being set to a deadline of an honours project.
My name is William Brown and I studied computer science at the University of Aberdeen. My project title was Automatically Recommending Code Reviewers in the open source project MediaWiki. Open source software is a specific type of project that allows submission by anyone and the code is viewable by everyone, which means that anyone can submit a patch, and in most cases, as long as you're trusted, anyone can review the said patch. The problem with this is that people who review are limited and they're also generally volunteers, so it means that someone submitting a patch may not be able to find that person for several weeks, several months, by which point the patch is out of date, it's no longer relevant. My project aims to find the best reviewer for a change who may submit patches and have no idea where their change is going to be reviewed, who's going to review it, how they're going to review it. And it means that this list gives them, at the time they submit a patch, a way of understanding, oh, this will be the best person to review. And if they're not active, they can go to the next person. So it allows someone who is very unfamiliar with the project to understand very quickly who's the best person for the job to review your change and then get it in quickly. My project created a command line application that allowed either a user who understands how to use the command line or an automated system to query who's the best reviewer for this change, and it would return those as a list that the computer can understand or the human can understand. My project could be used on the open source project MediaWiki, but it could have applications elsewhere. I built my project to start with an abstracted way of understanding about how you get those potential reviewers out. So I built the software so that I could write a new implementation that has different data sets, different everything. So the idea was that I could write it for something else and not do as much work. So I could see it being useful for other projects if more work was put in by developers who are more familiar with that project.
I'm Robertson. I studied applied computing at the University of Dundee, and my project title was Terrain Model Processing with Machine Learning. Digital elevation models are a store of elevation values which can be used to map terrain, and they're generally recorded using satellites flying over the body using sensors which are prone to errors. These errors result in voids where there's no data and so reduce the usefulness of the map. So I have developed an AI model which works off very similar technology to a field called image painting, which is the same way on your phone you can scrub out a person and it fills it in with the background. Essentially, it's using an AI model to create a best guesstimate of an unknown region based on the values surrounding that region. Digital elevation maps are very similar to images in the way that they're stored, and so we can also use this technology to fill in holes within digital elevation maps. Whilst there's already techniques for infilling voids, this project introduces the idea of using slope values, which is a calculation of the gradient surrounding a pixel, to encode the data in the DEM in a way that's much more easy for the neural network to parse, because there's greater differences between pixels. And also it combined this with a very state-of-the-art in-painting network, and the combination of both of these results in infill results which are more accurate than the current leading methods. For the future of the project, I would need to refine the paper a little bit because it's currently very much in a state for a dissertation, but I am very proud of the results, and I would be happy, and also have talked to my dissertation lead about the potential of publishing this in a conference paper when the time for submitting comes around.
I'm Andrea Martino. I studied software engineering in the University of Strathclyde in Glasgow, and my project title is The Use of Autoregressive Model Languages in the Classroom. So what we did was taking AI models that were currently out there in the world and try to apply them to generate educational content for primary school students, with the intention of lowering the dropout rate at later stages of their education, as well as making them more interested in education by itself. For example, the big thing here is a AI bot that speaks like Napoleon, and instead of reading through a text or a textbook, students get to chat with Napoleon. To do the experiment, because in the end this project was all experimentational, we split two groups. One used traditional educational resources, and other group used AI. In general, all the AI students interacted more with the application itself than the ones that use traditional content. It was good it was like comforting to see the people were actually interested by that, and they had fun interacting with them, trying to break it or trying to see if they knew more than him. I enjoy being in classroom, and if I didn't do anything related to software engineering, I would have been a teacher probably, and I just joining this work. Hopefully the university picks it up, hopefully develop their own language model for that, and they don't need to rely on the one that we are using, because we trained one that was already existent and it had its own bias, because they are trained with all the information in the internet, so that can lead to problems, especially when it's given to kids. They could include also more subjects to explore. This was focused for children between 8 or so. Maybe they could expand it to different years.